Let's start with the first most common and most basic function, the so-called scalability of encoder resolution. For the encoder resolution, we have to differentiate between incremental encoders and absolute encoders. For incremental encoders, resolution means the setting of the number of pulses per revolution. So here we just have a continuing sequence of pulses. And for absolute encoders, the adaptation of the resolution means also we are adapting the number of steps per revolution, but each step equals a distinct position. And for absolute encoders, this can be done as single-turn resolution, which means the number of steps per revolution, and it can be done as a multi-turn resolution, which then means the overall number of revolutions. The benefit of this is very clearly that the customer can directly and easily adapt the encoder and the encoder resolution to his application. And this saves a lot of efforts, for one thing, on the mechanical side, so there is no need for mechanical adaptation on the application, but it also notably reduces programming efforts on the PLC side of the application, because this adaptation of encoder resolution can easily be done directly on the encoder and does not need to be programmed on the PLC engineering tool side. Another benefit by doing this is the encoder itself can always be the same type, so the user can benefit from standardization of having always the same encoder on stock, and then adapt this one part to the different applications and to the different resolutions as it is needed. So it also facilitates the overall stock keeping for the user. How can this be used? Let's have a look at a first application example. Here we are looking at a linear measuring track on a crane. The encoder is assembled to a gear with a circumference of 300 mm. That means one encoder turn corresponds to a linear measuring range of 300 mm. The requirement for this application is to have one step equaling 1 mm. And this easily means we have 300 steps per revolution. Now the linear track all in all has a length of 12 meters. So this means our total measuring distance is 12,000 millimeters, equaling a total measuring range of 12,000 steps. How many revolutions are needed? In order to calculate this, we divide the 12,000 by 300, and this comes to a result of 40 revolutions. With this result, we can either go to the next higher value of binary revolutions, which is 64, or alternatively, if we want to set the scaling directly to the exact value of 40 revolutions, this can also be done with the so-called round access functionality that will be explained later.